Okay, so yes, as our evil supervillain said, a vector is simply an arrow that represents a vector quantity. Okay? Traditionally, people just call the arrow thing a vector, and that is true. The arrow itself represents a vector quantity. Okay? He talked about vectors and scalars. The word vector quantity and vector are basically interchangeable. Okay? Unless you're an absolute purist, then I don't imagine anybody here is. The length of the arrow represents the magnitude or size of the vector. In other words, the longer the arrow, the stronger the superpower. The direction the arrow points represents the direction of the vector quantity. Well, gee, who would have thought? Right? If the arrow points east, then the vector quantity is to the east. Okay? Any questions about any of that? Some of you may have jotted that down already. I don't know. Okay? And again, do you need all that? Can you summarize it in your own words? You should be able to. Vector quantity. So what the heck is a vector quantity? It's quantities that has a direction associated with it. They have size or magnitude and direction. Okay? These are the big four. Four vectors. The big four are displacement, velocity, acceleration, and force. There are others. These are the four that you're mainly going to be dealing with. Displacement, velocity, acceleration, and force. Okay? Scalars are quantities that do not have a direction associated with them. Here are a few examples. Mass, time, cost, just about anything you can think of that you measure, with the exception, of course, those. If you can say the thing that you're measuring and add the word south or north to it, then it makes sense that it's a vector. For example, I was driving at 100 kilometers an hour. South. Does that make sense? It does. Therefore, I shouldn't say speed, but velocity is a vector. If I could say, my lunch cost $4.75 east. Doesn't make a lot of sense. Cost is a scalar. Time. How long did it take you to get to Brandon? It took me 2 hours south. We might say that. When we say 2 hours south, what are we really referring to?
2 hours.
Pardon me? What quantity are we talking about? If I say 2 hours south, Brandon is 2 hours south of Rockland. I'm really talking about distance, right? Should we use time to measure distance? Probably not. We are implying that we're going to be driving at approximately 100 kilometers an hour, right? We should really say it's, I don't know, what's it, 160 kilometers to Brandon, something like that. Okay? Mass. You had to use a mass of 1 kilogram east in the lab the other day. Doesn't make sense. It's a scalar. Got the difference? You need to write it all down? Entirely up to you. All what you need to do is know the difference. You need to know the difference. Well, this exact thing will be up there. Just don't print it at school, please. Oh, now here's where it gets to be fun. Come and grab a clicker. Have we got them all? Okay. Come and grab a clicker. Which of the following properties of physics do you think is a vector? You have four choices: speed, density, momentum, or volume. A, B, C, or D, and then the word, and then the enter button.
Well, tell me if I'm right.
I might. There's only one way to find out.
You have to hit enter after?
You do have to hit enter after, yes. Well, let's see who got it right. Correct answer is C. Momentum. Now, you might say, Mr. Bennett, you said 100 kilometers an hour was a vector. And you might remember that I caught myself when I said, I better not say speed, I better say velocity. Because in fact, speed is simply the scalar version of velocity. It is velocity without a direction. It's how fast you're going, and I don't care what direction. Okay? Density, the density of this object is 3.6 grams per cubic centimeter south. Okay? Volume. This object has a volume of 1 liter east. Momentum. Momentum in a certain direction, right? Now, I was convinced, when Despicable Me 2 came out, I was convinced that the evil supervillain Vector would have a sidekick named Scalar Momentum. Or Scalar, that would have been a good one. Very disappointed to hear that wasn't the case. I think they should rewrite that. Yeah, Scalar would be a good one, right? Yeah. All right. Were you listening? Because I haven't clicked start the assessment yet. Which of the following properties from physics is a scalar? Gravitational field strength, density, magnetic field strength, or torque? If you are listening carefully, you will know. All right, who said the correct answer of B? Density. You were listening. Density is a scalar. Gravitational field strength. What's the direction of gravitational field strength? Down. Magnetic field strength. Magnets attract or repel. It could be, I'll just go sort of left or right. Attract or repel. Torque. Clockwise or counterclockwise. So guess what? These three are vectors. Okay. So, there's more. Relax. You know what? The clickers are amazing devices because I've never, ever, in all my years of teaching, classes come in and say, can we do a clicker quiz? They beg to have a quiz. I know they're fun. So, vectors. Vectors are represented algebraically by a variable with an arrow over it, such as this one for velocity. You don't need to write it down. You just need to know that if you see a letter with an arrow over top of it, it's a vector. Now, quite often when you're handwriting them, okay, people find having to make the little arrow thingy. See, I can't even do it. They find that hard. Okay? It is kind of hard. So you don't need to do that. It's common practice to write the V and then that. Just a half of an arrowhead. Okay? That's common. In the good old days before computers and all that, when textbooks had to be actually printed by a printer, they would have a hard time with all the symbols. They would simply show the V in a bold italics, and that was sort of one way to indicate that it was a vector. You'll probably never see that again unless it's an old textbook, but just so you know. Okay, when representing a vector, now here's a good example of something that you don't need to write everything down. When representing a vector graphically, you may move the vector any way you like, as long as the length and the direction which it points remains the same. Anywhere on the page. For example, the two vectors shown below are considered equal, even though they do not have the same starting points. These ones are labeled X and Y. Yeah, they are kind of blurry, right? But whether it's there or wherever, they're the same. How come? Because they're the same length and they point in the same direction, sort of at a northeast kind of direction, right? It is exactly the same thinking as this. Are those the same?
No.
Different symbol, but representing the same thing. A 2 and a 2, different places, different ways of doing them, okay? As long as the length and the direction are the same, then vectors are considered the same. Okay, now, you might say, Mr. Bennett, what units do I put after vectors? Because we all know that units are super important, don't we?
Yeah.
Oh, maybe we don't.
Better write that down.
Units are super important, by the way. On tests, I do doc for non-units. The answer is 14 meters, and you write 14, not complete. Okay? Now, I'm not a complete jerk. What I do is, if there's 3 questions on a page, and you've done it 3 times, I'll only take off a half mark for the whole page. But then the next page starts all over you. Okay, so units are important. So please remember them. But what about units of vectors? Well, it depends. It depends on the type of vector you're representing. A vector is not a quantity. A vector is a type of quantity. For example, displacement vector would be measured in meters. Velocity vector would have its magnitude measured in meters per second. Okay? What was I going to highlight there? I can't remember. I don't know. Okay? So, vectors don't have units. Vectors are just a classification of quantities. Meters are meters per second, right? We had velocity, we had displacement. What were the big four?
Acceleration.
Acceleration, which is in meters per second squared. And force, which is measured in, anybody know? Named after the big guy himself, newtons.
What's the A for again?
Acceleration. Acceleration is measured in meters per second squared. Force is measured in newtons. Americans like to measure force with pounds as well. What about the direction of a vector? Oh, now here we get into some fancy stuff. Direction of a vector can be measured more than one way. There are a variety of ways to measure direction. You have to be anybody French immersion in here? Somewhat bilingual? You're going to have to be more than bilingual with directions. There are many, many ways. A man is following scavenger hunt instructions. He is to walk plus 35 meters and then minus 10 meters. That doesn't sound like a particularly fun scavenger hunt. Plus 35 would mean 35 to the right. And then, of course, 10 backwards, right? And we would assume that to the right would be forward, and to the left would be backwards, right? Up, of course, would be positive, down would be negative as well. Pretty straightforward. Okay, what about this one? An airplane is traveling 200 kilometers an hour at 40 degrees south of east. Just ramped up the difficulty level quite a bit, didn't it?
Yeah.
All right, this one you might want to write down. This one's kind of funny. That's a pretty good example. 200 kilometers an hour at 40 degrees south of east. Okay. Never eat soggy wieners. Northeast, southwest, right? When you watch the 6 o'clock news, do you know why they call it the news? Information from all areas. Keeping in mind that 95% of the things I say are made up. But there's a 5% that I'm correct about, so you'll have to find that out for yourself. Okay? But you'll never ever forget northeast, southwest, will you? After I made that little comment. Believe it or not, people never mistake north and south, but for whatever reason, there's about 20% of the population that gets east and west backwards.
Is that the truth or a lie?
No, that is a truth. That is 5% truth. Truth. Okay. So we got south of east. South of east. Which way is east? East. That way. 40 degrees towards south. This way. So 40 degrees right in there, right? Does that make sense? 40 degrees south of east. East to the right, and then towards south, how far? 40 degrees. Most kids hate it when I say it that way. They don't like the 40 degrees south of east way. I don't blame you. Okay? Another way to say that is, and I've sort of got it poorly, let me see if I can do this here. That's better. East 40 south. What does that mean? Let's make a nice straight line here instead of those poorly drawn lines. North and south, east and west. Okay. East 40 south. East. Look east. And then go 40 degrees towards south. This one says south of east. You kind of got to start there. Right? Here it says east 40 south. Okay, it kind of flows a little better. If I said exactly southeast, what would that mean? It means 45 east. Very good. That would actually mean south 45 east. Anybody ever heard southeast? What does that mean? Google it up right now.
In between southeast and south.
Google it up. Southeast. What does it mean?
Between south.
Because to be honest, I can't remember the number.
2245.
Having said all of that about southeast, you're not ever going to see it really. But you might hear it like on the radio or whatever, right? But you might, from time to time, see in books and questions southeast. It means exactly 45. Okay? So there's sort of two ways of looking at things here. There's the 40 degrees southeast and east 40 south. Now, Mr. Bennett, what if I said, what if I'm talking about this angle in here that's in green? Oh, that was 40 then. What did I have here? 40? What if I'm talking about this angle here in green? Well, that would be, let's get rid of this here. The green, man, get rid of that. The green would be what? South 50 east. Notice what happens here. South 50 east. Oh, I went through my red, didn't I? This was east 40 south. The south and the east do what? Switch, and what happens to the number in between? They now add up to 90. What's that called when they add up to 90? My, that's a nice angle you have. Because they are, they're free, they're complementary. Like a complementary breakfast. Okay? The 40 and the 50 have to add up to 90. What is it called when they add up to 180?
Super compliment.
That would be good. Supplementary. Yeah. Whatever. Okay. Everybody get that? How that works, kind of? You may not get it 100% 10 out of 10 just yet, but we'll get there. Okay. Let's have a question here. The question is, which of these arrows shows the direction that's hidden here? Oh, I can't do that. Okay, well, which of these arrows shows the direction 30 degrees north of east, or east 30 north? East 30 north. How? During this exciting lecture? Please don't. Now, you only got two choices here, so you should get it right, I'm hoping. Did you press enter right?
I did.
Okay. Correct answer is A.
Yeah.
This one here is 30 degrees north of east. You always measure from one of these are called the cardinal points. Okay? Cardinal points, north, east, south, or west. You have to measure from one of them. Your vector is going to have to include one line that is a cardinal, east, or north, or south, or west. Okay, so if this one is east 30 north, what's this one likely to be? This is the opposite. North 30 east, right? Does that make sense? Give me the nod. Now I get it. Mm-hmm. Okay, last one. How much time have I got? A little bit of time. Navigators use this method. Now, I did a little search the other day about navigation. It is very confusing. I'll give it to you simply. Okay, this is known as the bearing method. You may have heard it on movies or TV or what have you. A sailboat is moving at a bearing of 210. This method assumes that 100 or 000 is north and revolves clockwise. So a bearing of 210 is like this. Okay, 000 is north. 090 is east. 180 is. Now 000 and 360 are the same thing. Generally, they just put the 000. Why the heck did they break the circle into 360 degrees? Blame it on the Egyptians, I say. You can look that up. I believe it was the Egyptians that came up with that. It'd be a whole lot easier if this was 100, 200, whoops, 300 and 400, wouldn't it? Wouldn't that be?
Who decided that was 360?
It was the Egyptians. I think so. There is actually a system where they break it into 100, 200, 300, 400. It's called the quadrant system. And on a scientific calculator, you know, there's degrees, radians, and there's also grad on your calculator. Have you ever seen that? That's what this is. It's not just a button you get to use after grade 12. Okay? But you don't need to know anything about that. Okay. So, where is 210? 180, 270, be down there somewhere, right? This angle here is 210 degrees. 210 could also be labeled south, south 30 west. South 30 west, right? South down to 180, 30 degrees, 180 plus 30 gives me 210 west. You will have one method that you prefer to use. That's perfectly all right. You need to be able to handle all sort of three. The general rule is, the convention is that if I give you the question in a bearing, you should give me the answer back in a bearing. Okay? Does that kind of make sense? Riley? Yeah? Other Riley? Emma? Yeah? I'm clear? Yeah? Okay. Guess what's coming up next? Which vector is that a bearing of 300? I like to put the bearings in square brackets because it sort of sets it off somehow. That's not really a convention other than my own. You'll notice sometimes there's a little degree sign in there, sometimes there isn't. So which one of those is at a bearing of 300? Is it A, B, C, or D? We're going to be waiting on Derosha, aren't we?
No, I have support.
Oh, did you?
Yeah.
Correct answer?
You're the one that said.
D is a bearing of 300. Okay? How many people got it wrong?
I did. I never answered it though.
Couple people.
I was.
Okay, make sure you know. Okay. How many people know what a scale drawing is? Yeah, to scale, right? Okay, a couple of points about scale drawings. Scale drawings are often used to represent vectors graphically. Example, a vector of 300 newtons down could be shown as. It would just be an arrow straight down. But if it's a scale drawing, then you need a scale, like 1 centimeter equals. What might I use for 300 newtons? 1 centimeter equals 30. Then you'd have to have it 10 centimeters long. Maybe 50. I would probably go with 50. Okay, 50 newtons. Would 100 newtons be okay? Absolutely. That's going to be up to you to decide. Please note, I can't stress this enough. Please note that all scales must begin with the words 1 centimeter equals. It's always the centimeter on the paper represents some number out there that you're thinking about. It is never 50 newtons equals 1 centimeter. That is just plain wrong. This way, 1 centimeter equals. Okay, that's the way you do it. If I ask you to draw a scale drawing, I would like to give 3 marks. 1 for the scale, 1 for the length, and 1 for the correct angle. Okay? If you're drawing it to scale, is it going to be exactly perfect? Like, let's say that this is supposed to be 6 centimeters long, but because you don't handle rulers very well, you made it 6.1. What am I going to do? Well, if I mark it wrong, then someone might say, well, what if mine is 6.05? And what if it's 6.000000001? Well, I'd be foolish to mark that wrong, wouldn't I? So where is the cutoff? Well, the cutoff is
6.5.
6 centimeters plus or minus 0.3. In other words, if it's supposed to be 6, you can be anywhere from 5.7 to 6.3. And if you're more than 6.3, you really don't know how to use a ruler, and you deserve to lose a mark. Okay? Like, come on, 3 millimeters? If you're off by that much, you're doing something wrong. Okay? Notice that I did plus or minus here. I did not use sig figs. In fact, sig figs in this particular case wouldn't actually work very well. Okay? 5.7 to 6.3. Same thing with angles. If it's supposed to be at 180 degrees, then that means I can have 180 plus or minus 3 degrees, which of course means 177 to 183. Do you need to write any of that down? No, you just need to remember I got to be within plus or minus 3. Okay, that's just sort of my rule. And it's more than generous. I haven't had any problems with it in the past. Most people are within 1 millimeter. Okay? 2 at the absolute most. Are we good? Okay, last thing we need to do today. If you have a ruler, use it. If you have a protractor, use it. If you have neither, come and get a high-tech ruler or a high-tech protractor, and using the high-tech cutting devices, get yourself a ruler or protractor. And I want you to spend the last 2 minutes of class drawing some scale drawings to get the hang of it. Okay?
Do we need a
You
ruler?
need a ruler and a protractor because remember, right? Size or magnitude and direction.